Hello everyone, continuing with our lecture series on balancing of reciprocating masses. Today in this particular lecture we will be starting balancing of V engines. Balancing of V engines, we will be deriving the expression for primary and secondary forces for V engines. This is also a kind of radial engine as it has a common crank. So let's start. So first of all, consider a symmetrical two-cylinder V engine. So I'll draw a figure. So we have, say, x-axis and a y-axis. So we have a symmetrical two-cylinder V engine. That means symmetrical means the axis of line of action are symmetrical about vertical axis. That means suppose this is cylinder 1, say this is cylinder 2, so this is a piston for cylinder 1, this is the piston for cylinder 2, and this is the line of action for cylinder 1 and 2. Let it meets here at P and cylinder 2 at Q. So this dotted line is inclined at an symmetrical angle, equal angle, say alpha with vertical. And this point, say O, this OQ and OP are the line of action for the cylinders. That means this OP is line of action for cylinder 1 and this OQ is line of action for cylinder 1, and these two cylinders which are inclined as a V engine with angle 2 alpha, that is angle alpha on each side, has a common crank, say OC. So I am making a common crank OC. Say this is a common crank OC which is inclined at an angle, say theta with vertical. So you need to understand the figure. Also this point C is connected with Q and with P. This CP and CQ are the connecting rods. So the figure is clear. Hope the figure is clear. So the line of stroke OP and OQ are inclined at an angle alpha with vertical, and theta is the angle which this crank, that is the common crank, is making with vertical. So all you need to understand here is the angle between crank and line of action for first cylinder, how much it is? That is the angle between crank and line of action. This is very important. So this angle is how much? This angle is alpha minus theta, that is equals to alpha minus theta. This is the main logic. If you understand this, then the derivations become very easy. Similarly, the angle between the crank and the line of action for cylinder 2 will be alpha plus theta, that is between the crank and the line of action So from here till here it is theta plus alpha. For cylinder 2 it is alpha plus theta. Why I am telling all these things is, this is very important. So angle between crank and line of action for second cylinder is how much? It is alpha plus theta. Why I am telling this is, actually while calculating the inertia force, or when we have derived the expression for acceleration of a reciprocating part or acceleration of a piston, there we have derived an expression that is acceleration of piston along line of action what we had is, we had a crank, slider crank mechanism, in which we had a angle theta. For that we calculated acceleration whose magnitude was r omega square cos theta plus cos 2 theta by n, where this theta was, what is this theta? This theta was the angle made by crank with line of action. This theta is for this particular case I am saying. So when we will be deriving the expression for cylinder 1 and cylinder 2, so this angle theta which we are taking here is the angle, if we are considering cylinder 1, it will be between line of action and crank, it is alpha minus theta for cylinder 1, and it is alpha plus theta for cylinder 2. This is the main logic behind. Clear? So now for our figure, that is balancing of V engine, that is a symmetrical V engine, this figure is clear. So let this particular example I am taking, I have taken just for this figure. Now theta in our case is the angle of between crank and vertical. So let small m represents the mass of reciprocating parts, per cylinder. Yes, small l, same nomenclature, that is length of connecting rod. Small r is the radius of crank. Small n represents the ratio of length of connecting rod to the radius of crank. Theta here is the inclination of crank to the vertical axis. Yes, and omega is angular velocity of crank, that is this crank is rotating with constant angular velocity, say omega. Yes, and what is this alpha? Alpha is the angle made by line of action with vertical axis, or we can say 2 alpha is the angle of the two cylinders of V engine. Clear? So now what we need to evaluate is, we will be deriving the expression for F P1, that is primary force for cylinder 1 along the line of action. We will be deriving the expression for F S1, that is secondary unbalanced force for first cylinder. Similarly, along the line of action for second cylinder, we will be deriving an expression for FP2. FP2 is primary force along the line of action for cylinder 2, and finally we will be deriving an expression for FS2, that is secondary unbalanced force along the line of action for cylinder 2. So we will be evaluating FP1, FP2, FS1 and FS2. So let's start. So hope this much is clear. So we will be requiring this particular figure again and again, so that is why I am keeping it safe. So we know that, now let's start the derivation. We know that inertia force due to reciprocating parts for cylinder 1 along line of stroke, how much it is? That is mass into acceleration, that is mass into acceleration, which is equals to mr omega square cos. Now since theta for our cases, that is angle between crank and line of stroke, it is alpha minus theta. So we will write, this is the main logic behind. So we'll take alpha minus theta plus cos 2 alpha minus theta upon n. Hope it is clear. Yes. So we can write it as mr omega square cos alpha minus theta plus mr omega square cos 2 alpha minus theta upon n. Yes. Hope it is clear. Now similarly, in the same way, inertia force due to reciprocating parts for cylinder 2 along line of action. Along line of action, what I mean to say is, again I am showing you the figure, that is OQ for cylinder 2 and for cylinder 1 it is OP. This I am writing just to make you remember. So what will be the expression? Same, inertia force is mass into acceleration, that is mr omega square cos. Now again this theta is, that means angle is between crank and line of action. Now for cylinder 2 it is alpha plus theta. Hope it is clear. Alpha plus theta. So it will be alpha plus theta plus cos 2 alpha plus theta upon n. So we can write this expression also as mr omega square cos alpha plus theta plus mr omega square cos 2 alpha plus theta upon n. So what I did is I calculated the inertia force due to reciprocating parts for cylinder 1 and inertia force due to reciprocating parts for cylinder 2. Now, as we have done in the previous derivation also, what is this? This is primary unbalanced force and this is secondary unbalanced force. So this is primary unbalanced force for cylinder 1, that is, hope you remember, this mr omega square cos alpha minus theta is fp1, that is primary unbalanced force for cylinder 1, and this is fs1, that is fs1, that is secondary unbalanced force for cylinder 1. Similarly, what is this? This is fp2, that is primary unbalanced force for cylinder 2, and this mr omega square cos 2 alpha plus theta upon n is secondary unbalanced force for cylinder 2, that is fs2. Now this fp1, fs1, fp2, fs2 are along the line of stroke, that is this fs1, fp1, fs2, fp2 are along the line of action. Now what we are trying to do is we will be deriving the total primary unbalanced force and total secondary unbalanced force. So now first let's start with this. Hope this is clear. So now to calculate the total, now first we will consider primary forces. Let's start. So first of all, we know several things, that is we know that primary force acting along line of stroke for cylinder 1. Line of stroke and line of action is same. Somewhere I am writing line of action, somewhere I am writing let it be line of action only, that is the line along which the piston reciprocates. So this fp1 is how much? mr omega square cos alpha minus theta, that is mr omega square cos alpha minus theta. Let it be equation 1. Now component of fp1 along vertical OY. What we will do is we will take the components along horizontal as well as vertical. So this is FP1, it is inclined at an angle alpha with vertical, so it will make how much? I'll show you. With vertical it will be FP1 cos alpha. Remember, this cos alpha is with vertical. Sometimes what we do is we take with horizontal, so this is the mistake that we take. So FP1 is along line of action, so along OY it will be FP1 cos alpha. Similarly, along OX it will be FP1 sin alpha, since these OX and OY are perpendicular to each other. Similarly, for FS1 it will be FS1 cos alpha, and along OX it will be FS1 sin alpha. Currently we are taking the primary forces, so along, for first cylinder, along OY, along vertical it will be FP1 cos alpha, and along horizontal, that is OX, it will be FP1 sin alpha. Similarly, for cylinder 2, along OY it will be, it is this FP2 is inclined at an angle alpha with vertical, so it will be FP2 cos alpha, and for FS2 it will be, I am writing up, FS2 cos alpha. Hope you are understanding what I mean to say. In the same way, along OX it will be in opposite direction, that is the component of FP2 along OX will be FP2 sin alpha, and for FS2 it will be FS2 sin alpha. So this is what the all logic behind. So hope the figure is very clear. So if this is clear, that means 90% of your problem is resolved. So now let's take the same. First we are considering the primary forces. So primary force acting along line of action for cylinder 1 is mr omega square cos alpha minus theta. So component of FP1 along vertical OY will be FP1 cos alpha, that is mr omega square cos alpha minus theta into cos alpha. This FP1 I have written from here, cos alpha is cos alpha. Yes. Similarly, component of FP1 along OX, that is component of FP1 along OX is FP1 sin alpha. So it is FP1 sin alpha, which can be written as mr omega square cos alpha minus theta into sin alpha. In the same way, for cylinder 2, primary force along line of action for cylinder 2, that is FP2 is how much? Yes, from this, here we have derived this. FP2 is how much? mr omega square cos alpha plus theta. These are the conceptual things, but when you start deriving it becomes very effective. So it is mr omega square cos alpha plus theta. Now same way, component of FP2 along vertical OY is FP2 cos alpha. Yes, that is mr omega square cos alpha plus theta to cos alpha. Yes, so let me write these as equations. So this is be equation second, that is component of fp1 along vertical. Let this be equation 3. Let this be equation 4. Let this be equation 5. Yes, now horizontal component of fp2 along horizontal ox will be how much? fp2 sin alpha, that is mr omega square cos alpha plus theta into sin alpha. Let it be equation 6. Yes, so now we have derived the primary and balanced force for cylinder 1, primary and balanced force for cylinder 2 along the line of action, then along vertical and along horizontal. Now total component of primary force along the vertical line will be, that is total component of primary force along the vertical line OY, that is total component of primary force along vertical OY will be how much? So along OY total component will be fp1 cos alpha and fp2 cos alpha, that is fp vertical total will be how much? Vertical, that is equation second plus equation fifth, that is fp1 cos alpha plus fp2 cos alpha. So we can write it as mr omega square cos alpha, hope it is visible, into how much? Cos alpha minus theta plus cos alpha plus theta. So what is cos a minus b plus cos a plus b? Let me write it in another page, next page. So cos a minus b plus cos a plus b, trigonometric formula, how much is it? It is, yes, 2 cos a cos b. So here a is this alpha and b is theta, so we can write fpv equals to how much? You can see here 2 mr omega square cos square alpha cos theta. So this is the total primary force along OY. Let it be equation A. Now and total component of primary force along the horizontal line OX. So let it be represented by FPH, that is total horizontal component of primary force along line of action. So total component of primary force along the horizontal line OX will be how much? It will be horizontal component of FP1 along OX and horizontal component of FP2 along OX. But you can see that in this particular figure, FP1 is in positive x direction and FP2 is in negative x direction. So it will be how much? It will be FP1 sin alpha, it is not cos alpha, it is sin alpha. FP1 sin alpha minus FP2 sin alpha, that is FP1 sin alpha minus FP2 sin alpha. Why negative? Because they are in opposite directions when the components are being resolved. I'll show you this also. Component of FP1 sin alpha, that is equation 3 minus component of FP2 along horizontal, that is equation 6 minus equation 6. So I am writing directly, it is mr omega square sin alpha common, it is cos alpha minus theta minus cos alpha plus theta, that is equation 3 minus equation 6. So again we know that cos, formula for cos A minus B minus cos A plus B is how much? Is how much? Yes, it is 2 sin A sin B. This is the trigonometric relation. Yes. Now FPH will be how much? mr omega square, I am writing directly, it is sin square alpha sin theta. So this is our total horizontal component of primary force. Let it be equation B. Now from equation A and B we have got the relation for primary force along vertical and primary force along horizontal. Therefore resultant primary force will be how much? That will be say FP, it will be, yes, the vector sum of the horizontal and vertical component, that is FPV whole square plus FPH whole square. So finally from equation A and B it will come out to be how much? 2 mr omega square under root, I am writing directly, cos square alpha cos theta whole square plus sin square alpha sin theta whole square. So this is what? This is the expression for the resultant primary force for the V engine, two cylinder symmetrical V engine. This is resultant primary force for symmetrical two cylinder V engine. Now the following result derived from this particular expression can be kept in different ways. Putting the different values of alpha, putting different values of theta, we can derive in the expressions. And one thing very important, you can note down also, since both the cylinders are rotating in with the common crank, since rotation of this I should have told you in the beginning, but since the rotation of crank is same as they have the common crank, therefore we will be deriving an expression for only unbalanced primary and secondary forces. Therefore there is no primary, or they have the same plane, so they have no primary or secondary couples. This is very important. This you note down, that since the rotation of crank is same, that is they both the as you can see figure also, both these cylinders are rotating about the common crank OC, so they have the same plane of rotation. Therefore only the unbalanced primary and secondary forces are there, but no couples. So primary force, it is clear. Now let's start with secondary. Now next is exactly in the same manner we will be doing for considering secondary forces. Hope it is visible. Yes. So very fast we will derive. We know that secondary force along the line of stroke for cylinder 1, that is secondary force along line of action for cylinder 1, it is Fs1. The magnitude is how much? mr omega square cos 2 alpha minus theta upon n. Hope you remember. Fs1 is mr omega square cos 2 alpha minus theta upon n, and Fs2 is mr omega square cos 2 alpha plus theta upon n. So this is the secondary force along the line of stroke for cylinder 1. So we will take its both vertical and horizontal component. We will derive in the same way that the way we have done for primary forces. Now component of Fs1 along OY will be how much? Fs1 cos alpha, which is equals to mr omega square cos 2 alpha minus theta upon n, that is Fs1 into cos alpha. Yes. So there we have derived till equation 6. Let it be equation 7. Similarly, component of Fs1 along OX will be Fs1 sin alpha, that is mr omega square cos 2 alpha minus theta upon n into sin alpha, let it be equation 8. Now for second cylinder, for that is secondary force along line of action for cylinder 2, that is Fs2 is how much? Fs2 is how much? mr omega square cos 2 alpha plus theta upon n, that is mr omega square cos 2 alpha plus theta upon n. Now we will take its horizontal as well as vertical components. So component of Fs2 along OY will be Fs2 cos alpha, which is equals to mr omega square cos 2 alpha plus theta upon n. Hope you are understanding. We are just deriving the same way we have done previous one. Alpha, let it be equation 9. Similarly, component of Fs2 along OX, it will be in opposite direction, that is here you can see Fs2 sin alpha, that is component along OX, Fs2 sin alpha, I am just writing without taking the sign, Fs2 sin alpha, it will be mr omega square cos 2 alpha plus theta upon n into sin alpha. Let it be equation 10. Now total component of secondary force along vertical OY will be vertical component of cylinder 1 and vertical component of secondary force of cylinder 2, that is equation 7 plus equation 9. So let me write. It is a long derivation but very effective. Total component of secondary force along the vertical line OY. So along OY, that is secondary's vertical will be how much? It will be equation 7 plus equation 9, that is equation 7 plus equation 9. So how much it is? It is mr omega square cos alpha upon n common, yes, then in bracket we will write cos 2, how much? Cos 2 alpha minus theta plus cos 2 alpha plus theta. So what I have done is, I will show you with figure also. Now for secondary forces I have taken Fs1 cos alpha and Fs2 cos alpha. So that is equation 7 and equation 9. Our equation 7 was, let me show you also. Equation 7 was mr omega square cos 2 alpha minus theta upon n cos alpha, and equation 9 was mr omega square cos 2 alpha plus theta upon n upon cos alpha. So I have taken mr omega square cos alpha upon n common. So now cos a minus b plus cos a plus b, how much it is? write directly. We have just written in our previous expression also how much it is. I'm just writing the answers directly. I'm expecting from cos a minus b plus cos a plus b. How much it is? That is 2 cos a cos b. This you need to remember actually. So finally the vertical component comes out to be FSV is how much? M r omega square upon n. Yes, cos alpha, very good, into 2 cos 2 alpha cos 2 theta. Since this is 2 alpha minus theta, 2 alpha plus theta, this is 2 alpha plus 2 theta, this is also 2 alpha minus 2 theta. So finally it comes out to be how much? 2 mr omega square upon n cos alpha into cos 2 alpha into cos 2 theta. This is what FSV. That is the total vertical component of secondary force along OY, that is vertical component. Let it be equation C. In the same way, total component of secondary force along OX, that is horizontal line, that is FSH. How much it will be? It will be the component, it will be the, how much? I'll show you. It will be the, for cylinder 1 the second along OX, and for cylinder 2 along OX, that is the secondary force for cylinder 1 along OX, secondary force along OX for cylinder 2. So how much it is? That is equation 8 minus equation 10, that is equation 8 minus equation 10. So we can write directly, that is mr omega square sin alpha upon n. Why the direction, why we have taken minus? Hope now it is clear. It is negative because this fs1 sin alpha and this fs2 sin alpha, they are in opposite direction. This is in positive x direction, this is in negative x direction. So for the vector sum we have taken negative. So it comes out to be mr omega square upon n sin alpha into cos 2 alpha minus theta minus cos 2 alpha plus theta. So again for this we know that cos a minus b minus cos a plus b will be how much? 2 sin a sin b. So putting this expression here for 2 alpha minus 2 theta and 2 alpha plus 2 theta, finally FSH will come out to be mr omega square sin alpha upon n into 2 sin 2 alpha sin 2 theta. So we can write it as 2 mr omega square sin alpha upon n into sin 2 alpha into sin 2 theta. Let it, this is the total component of secondary force along horizontal line, that is secondary component along horizontal line. Now we, for secondary forces, we have got the total vertical component and we have got the total horizontal component. Let it be equation D. Now total secondary force Fs will be under root of F vertical component whole square plus horizontal component, secondary horizontal component whole square. So finally you will get the answer. Yes, you can do yourself. So resultant, this is what this is. This is what this is. Resultant secondary force. I am writing it again. This is resultant secondary force. So Fs will be how much? Under root of Fs v square plus Fs h square, that is equation C square plus equation D square. So we can write directly, it is 2m upon n r omega square under root cos alpha cos 2 alpha cos 2 theta whole square plus, I am writing it below, sin alpha sin 2 alpha sin 2 theta whole square. So this is the expression for resultant secondary force of a symmetrical V engine. Hope it is clear. So now what we can do is we can derive the different relations considering different values of alpha. So hope it is clear. Yes. So you can derive the expression for Fs and Fp taking cases as alpha equals to, say 2 alpha equals to 60 degree, 2 alpha equals to 120 degree, and so on. So hope it is clear. So thank you so much.